Hey guys, what's up? So this is going to be a new format. If you've ever watched YouTube tutorials before, if you've ever watched my tutorials in the past, this isn't really a tutorial. In fact, one of the things that bothers me about tutorials is that as a content creator, and somebody that actually taught myself how to program, and now I'm a professional programmer, I never really use YouTube tutorials for the most part. They were too all over the place. Basically, you had a large combination or a large variant of people that had no idea what they were talking about compared to some of the ones that did know what they were talking about. And their curriculum, either copied off of each other or just didn't really seem to follow down a real efficient path for me to be able to adopt it. So if you want to do more than scrape the surface with a framework, you need to dig in and dig in deep and start messing around with it. You need to break stuff because that's going to be the way that you're going to learn how to code. So in this new series, I just aim to go in and learn a Python. Well, in this case, we're going to be learning Python requests. But this is just one programmer's point of view. I'm not the best programmer in the world. I'm a senior C# programmer, so I do a lot of C# and JavaScript. Python's always been a hobby of mine, so there's going to be ways that I write my Python code that may not be like the Pythonic way. However, this is just going to be a series where I go through and try to learn a library for the first time. So that being said, I'm not going to break this up into a bunch of different tutorial videos. This is going to be just one long video. One of the things I also don't like about YouTube tutorials or even really good tutorial sites like Pluralsight is that they do break it up into so many different friggin' modules. Now, in some ways it's good because you can jump around and things like that, but in some ways it's like, dude, just get to that effing point. Let's get into some code and start figuring stuff out. Let's break stuff. Let's not make it all scripted and perfect and everything. So, this is going to be, like I said, this is going to be a different type of tutorial. So all that said, first things first, you need to have Python installed on your machine. So when you pull up a command prompt by going into Windows and typing cmd or whatever sort of operating system you're using, just pull up the shell and type Python. If you don't have it installed, you need to install it. If you want to watch videos on how to install it, like with me, Python, how to install Python. I have one video on here that is relatively popular on how to install Python and get it all set up here. If you follow the Python 3.5 tutorial, that'll show you everything you need to do. So you can just type Google, Chris Hawkes, how to install Python, and that'll show you how to do it. But hopefully you guys can figure that out. It's just an easy installer if you're on Windows. But by typing Python, it'll pull up the shell so we can actually run a Python statement by saying hello world, and you get Python there. So let's go ahead and close that. Next thing we need to do is we need to go in our projects directory. So you don't have to do it this way, but you want to have some way of storing your code. So I'm going to have my Python requests folder. In fact, I'm going to call it the full learning Python request. So if we go inside here, I want to do a little shortcut in Windows by typing cmd, and that's going to open up a command prompt for this new folder that I just created called Learning Python Requests, which is in my projects directory. And here I'm going to run the virtual env command. So this is going to create an isolated environment. So any sort of Python work that you do, you want to get into a habit of making sure that your environment is isolated. And it's relatively easy to do, but very confusing if you've never done it before. But just type this in. These are hyphens, and make sure there's 2 hyphens here. What we're doing is we're saying virtual environment, which comes with your Python installation if you're using Python 3.5. We're saying env, which is the name of the virtual environment that we're creating, but this could be anything you want. It could be called, boobies or your mom, or it could be called anything you want it to be called. But I just call it env, short for environment. And then this no site packages flag, that tells it, hey, if there is a module that is part of your global Python installation directory, don't share that module, just reinstall it for this environment. So basically you don't ever want any sort of sharing going on, so that's why I do that. So this is going to go out, it's going to actually install pip, which is the package manager. So in order for us to install Python requests, we're going to use pip, and you're going to see here that it's installing pip right there. But once the environment is set up, we actually need to activate the environment. So that's what we're going to do once this is finished. So if we go and do a dir on the directory, you can see that there's now an env folder. Let's go ahead and cd into it and look at the contents. There's a scripts folder. We want to cd into the scripts folder. And if we look in there, we can just simply type activate. Now, if you notice on the left-hand side in parentheses, it says env. So that means that we actually have the virtual environment activated. So if we run pip install now and we install requests, you're going to see that it's not going to install it globally, for all Python projects that you have. It's going to install it just for this one particular project. So if we wanted to see where it installs to, we can go into lib, go into site packages, and then you can see requests is now in the directory inside of there. Next thing we want to do is we want an editor in order to be able to write code. There's a few editors that you can choose, and once again, I don't want to be all opinionated about saying that you need to use this or that, but I'm going to use Visual Studio because Visual Studio has a lot of cool stuff. Here's Atom. Atom has support for Python, but it's a simple text editor. It's not something that allows you to create and run projects easily. I use Visual Studio because Visual Studio is a great editor. It has a lot of tools for you, but they keep getting better when it comes to like Python tools for Visual Studio. This is a pretty good project. So you can see, you can actually step through your Python code. You'll be able to see even like performance stats and stuff like that. So it's going to be rather daunting if you're first getting started. But Visual Studio is definitely an editor that you would want to learn because a lot of corporate jobs, in case you ever get a corporate gig, you're going to be using something like Visual Studio or Eclipse, and Visual Studio is much better than Eclipse in my opinion. So that said, I want to go ahead and open up Visual Studio if you haven't installed, and I'm going to say new project. And under here, because I have Python tools installed, I can click on Python. I'm going to say from existing code. I want to give it the directory where I'm currently located. So we put it in Python, what do we call it? Python requests, right? Or learning Python requests. We say learning or using. What the fuck did I call it? Oh, here it is. All right, there it is. All right, so I'm going to say select that folder, and we'll just call this. In fact, I'll name the Python project the same thing with no spaces. Learning Python requests. We click OK. Now inside here, you can just say next. And then this says global default or detect an auto virtual environment. In fact, I just want it to detect because it should find it. So when we say detect virtual environment, that should be fine. So now in Visual Studio, on the right-hand side, you're going to see the Solution Explorer, and it's going to be kind of small font, unfortunately, for these project directories. But you can see that it did find our environment, env, and you can see if we open up env, you can see requests is inside of there. It's the only module that we installed in this Python virtual environment. One of the things that you're going to want to do is click on this button called Show All Files. Because in the env folder, this is actually where we can go into lib and go into site packages and then into Python requests. And I can actually go into Python requests, and if I right click it, I could say include in project. And this is going to take just a few minutes. Well, actually it took a second there. But now this is all the source code to Python requests, so I can pull it up inside my editor. And I can even place breakpoints and stuff like that, which is pretty sweet. So all that being said, let's go ahead and minimize some of this stuff, and we're going to go over here. We're going to right click on the actual project file, so learning Python requests, and we'll say add new item, and this is a empty Python module. We'll just call this start.py. So in here, let's go ahead and say import requests. Okay. Now let's just say variable test equals request.get, and then we're just going to say get the website hipstercode.com, and if I say print test, I'm actually not even, see, once again, that's me being not a typical Python programmer. var is something I would use in either C# or JavaScript. I'm sorry. That's the kind of stuff that happens when you're writing multiple languages at one time, especially when Python's just a hobby of mine. So anyway, we're going to say test. We created a variable and it says request.get. So this is actually going to return the status code, I believe. But the good thing about Visual Studio, and I'll make this a little bit bigger. The good thing about Visual Studio is I can just click start and it's going to run this. But this says, hey, your project needs a Python script marked as startup. So what it means is go over to Solution Explorer. And if you want to pin this open, you can click this little pinhead thing and it'll stay open for you. But I want to click on this start.py, right click and say start or set as startup file. So now this Visual Studio knows which file to start executing, because if you're doing Python, Python doesn't need like a main or anything like you would need with C# or Java or something like that. But here I click start and you can see it's running the Python emulator there, and you can see it prints, and it's actually very friggin' small. Let me see if I can make it bigger. Alright, so that's a little bit better, but you can see it prints the response code, which is 200. So if you guys have ever used HTTP, you know that HTTP has built-in codes that mean all kinds of different things. So let me see if I can do a quick Google search on that. Some of the common ones that you guys probably know about is like 404, like page not found and all that stuff. But here's all the different successful responses: 200, 201. Here's like a redirect, which is a 301. You got the 404 page not found. But if you want to go over this documentation, you can see that there's tons of different response codes. But 500 means something got screwed up. You have an internal server error. So there's all kinds of different stuff. So this thing says, hey, we requested hipstercode.com. We assign the value to test. Now, what is test? Let's go ahead and see what test is. So when we say type test, let's go ahead and print that. And we see, okay, it's a class. And it's a class called request.models.response. So let's see in our env, when we say, let's go ahead and open up Python request, and it says models. Here's the models file, and then what else did it say? Okay, if I pull this up, it says models.response. So we know that if we look inside here for response, I'm going to say Control F and do response. That's not it. Here's the response object. So here's the class. This is the class type that got created for us. So here's all the init code. So we know that this has all kinds of stuff. Like here's a function, an internal function called getState. So let's call this getState on the object and see what happens. So if I said, we'll remove the type, and let's just say test.getState, and this needs to be a dot. Let's just see what happens if we print this. And this is the kind of stuff that I'm talking about. This isn't a scripted tutorial. This is me monkeying around with stuff. But you can see bound method response.getState of response 200. I don't really know what that means, but we're stepping into actual source code. So let's go back to our models file and keep this open. I want to put a breakpoint right here. I want to see if we can hit the breakpoint. So let's go ahead and click the little stop button, and we're going to run this again. Click play. The Python emulator does not hit the breakpoint. That sucks ass. Okay, so I was hoping that this would hit, but apparently it's not going to. Let's see if we can call. So here's this text, right? So if we wanted to actually get the HTML source, and I know this from monkeying around with Python requests in the past, but if I wanted to say, print out all the HTML source code and everything, I could just simply say print test.text. Now we're running into an encoding error. So you can see it says char map codec can't encode character UFEFF in position 0, character maps to undefined. So for some reason, this is giving us an encoding error. Now, if I looked at the documentation for Python requests, it says that it should encode it in UTF-8 by default, but apparently that's not working very well. So if I explicitly say encode it to UTF-8, I can somehow get around this problem. I know this from the past, but it's kind of a weird issue. But here, this is going to now print all the HTML source code for the web page, hipstercode.com. So if I wanted to, a more applicable thing instead of printing, you could simply say like out file equals projects. What do we call this? Learning Python requests. I'm going to say test.txt. So here's our out file. We could say open no, we're not going to do it. We're going to say out file equals open, and then we'll pass in this value, and we'll give it the second argument of w for write. I haven't done this in a while. And let's say outfile dot write, and we're going to write out this junk. All right, so what we're going to try to do is, as long as this path is okay, this should build a test.txt file and put it into our project's root directory. So it says must be a string and not bytes. Okay. All right. So we can what's called convert or cast this to a string. So by saying str and then wrapping it in parentheses, we can tell it to just cast this and do basically ignore it. Open, just write the goddamn file. You know what I mean? That's all I needed to do. So let's look up the folder now, and here's test.txt. So we wrote to an out file. So you can see here we got all this this source code. Here's those weird characters that apparently are showing up in that HTML file for some reason or another. But now if you look at the formatting here, it looks all jacked up. So well, we should probably encode it a little bit better. So let's go ahead and go back to our Visual Studio here, and I'm going to say, instead of explicitly staying in code, what I can do is I can actually change outfile by saying outfile dot encoding equals ISO 88 blah blah blah, and let's go ahead and try to write this now. In fact, not outfile, but it's going to be test.encoding. I'm sorry, because test is the name of our variable, our class object for Python requests. So we're changing the encoding using built-in abilities of Python requests in order to change the coding to this ISO, which don't even ask me what that means. I don't even really know. It's just a standard. Let's go ahead and press play. So now if we go ahead and we check out tests, oh, much prettier. You can see it's much prettier. And this is all just the source code to the hipstercode.com website. So obviously, say you had a list of URLs where you needed to get all the source code. You could have Python list. So my list of, let's do it the Python way. My list of links. Python likes to use underscores for variable names, and then here could just be a set of strings where we have a bunch of different URLs. So let's go hipster code. Hipster code will be the first one. The second one, let's go ahead and just do hipster code.about. And you guys get the point. We don't need to do more than 3, but you could have a list here. So instead of saying test, we could say for, let's just say for test in my list of links. My editor should try to find that for me, but it's not apparently. We'll just say for link in my list of links. That way we can go in here and say get link. And we'll go out file. And now let's be a little bit smarter about our test file. We'll say plus link plus. Now, one of the things though is that's not going to be a valid file name, so we can't name it link actually. Let's go ahead and do, we'll just call this test. Yeah, that's fine. We'll just do this real quick. Let's just mess with this real quick. Let's go ahead and press play. One of the things that's good is that I can set a breakpoint inside here, and if we go ahead and we start this, we'll actually hit the breakpoint now since we're inside the code. And if I go ahead and I hover over test, or I can hover over link, and you can see link it's processing the first one, which is, oh wait, that's not even right. Okay. I'm not sure why. Oh, you know what? Because I didn't put a comma. That's stupid of me. Your list items need to have a comma there. So see, I was missing a comma, so link like made both of them all one string. Okay, that's funny that it actually didn't throw an error message. That's Python for you, man. Not even throwing the error there. All right, so now we're processing the first link in my list of links. So here we go. So test is get, and here's the response. If we can look at the response type, and you can actually go down here to text, and you can see all the content down there. So now we're going to open up the out file, and now this is where we're going to throw the error message, because here you can see that there's all these special characters that you can't have included inside of here. So one of the cleaner ways that we can do something like this, because obviously we can't have a link be a part of a file name because it includes all these characters that you can't have in a file name. So we'd want to use something like the enumerate function in Python, which allows us to be able to get an index number. So I could say for index link in my list of links, but I'm going to say enumerate and then put my list of links inside the parentheses. And then by doing this here, I can go and instead of saying link, I'm going to say index. Yeah, index. But since index is an integer, because this will send back the actual, value, like the integer value. So this will be 0 and this will be 1 of where this position resides in the list. So that's not going to be, you can't add a string and an integer without actually converting the integer to a string. So let me show you what I'm talking about. So if we press play here, I can say for index, see, this is a 0, and then here's the link. And now if I go ahead, it'll open up the out file, it'll do the encoding, it'll write it. Now we're in the second item of our list. And now our list is finished, so the program is finished. And if we look at our file, we now have test 0, and you can see this is the home page, hipstercode.home. And then here is our second page, and you can see hipstercode.about. So those are two separate pages that we requested. And ideally, like maybe you go and you start parsing the web and get millions of links, like Google. I mean, they're going through millions of links and following links and stuff like that. And you could do the same type of thing with Python requests, because I'm not doing anything special. I basically say, here's a list of URLs, and go ahead and parse them. Now what I could also do is, if you looked at the source code, I deleted the file, but if you go in there, you could actually start parsing all of the the contents of the actual page using something like Beautiful Soup in order to parse out like all the links to it, to a page or something like that. So let's start looking at a few other things here. So in our list, instead of us writing to an out file, we've already seen how we would do something like that. Let's go ahead and get rid of all this out file stuff. And within our test, we're going to just say print test. My editor keeps doing that. If it does that and you don't want to do it, you have to press escape. And we're going to look at the, we'll look at, let's look at, I guess, headers first. So let's take a look at the headers for test and just see what kind of headers we have, if anything. So here's the first type. You can see the content or the headers that are sent to Hipster Code when we're talking about making this request across the web. So you can see there's content length, and then there's cookies, accept coding. You can see the kind of server that is sitting alive on hipstercode.com, which is Nginx. It's actually a reverse proxy server there, but that's not important. So those are the headers. Let's see if there's any cookies here. So we could say cookies. And if we do this, watch what's going to happen. We're going to actually get cookie objects returned back to us. So this cookie jar. So it's like, well, how do we get those values? So we could say get, I think it's called dict or something like that. And that's short for dictionary. I don't remember. This might not be right. Okay, that is right. So you can see that there are no cookies being retrieved from our Python requests of going to hipstercode.com. Now instead of this, let's go ahead on the third one. Let's go to Google. So we'll say http www.google.com. And if we run this, so here's this third one. This is Google actually setting some of their cookies. So you can see that's how you would retrieve cookies from any sort of request that you make. Sometimes you have to actually get data from a cookie in order to include it with a post or something like that if you're going to be requesting certain data. So that's why both headers and cookies are important. All right, the next example I want to show you is if we go to google.com and we just search here and we type test, you can see the query string is this q equals test. So if I went ahead and I said, you know what, okay, that's the URL, and we'll replace this right here. Let's get rid of these other two links. So here is this this test, and we're not even going to worry about this for right now, but what I want to do is just we'll just say that for right now. So Python request has the ability inside the get, where we're doing the get right here, I could say, you know what, I want to go ahead and say payload equals, and this is going to be a dictionary. So dictionaries are key value pairs, and we'll just say our first key, what is the value here? So it's Q. So we'll say the first key is Q. Instead of equal, we're going to say its value is test. So here is our payload right there. And then with the get, we could do second argument. We could say params equal payload. Now let's see if we get any sort of value back. Instead of test, I'm going to see test.text. We might need to turn that to a string, but we'll try. It should be a string by default, actually. So here we go. So this thing printed a bunch of stuff. So basically, all this stuff is part of what we search for in Google. And this is typical of Google, so there's a lot of stuff in there that you have to look for. Now, if I wanted to, with test, I want to say test.url, so we can actually print the URL just to see how those query string parameters got appended. Make sure those look right. So you can see it by default, the query string in Google is using a £, but it should also, and typically when you do a query string, it's always a question mark with a key value like Q equals test. And if we did another one, like if we added another argument here, so we'll just say test equals testing. You know, they are separated. Each query item is separated by an and symbol, which is the typical way that HTTP requests are done. So here's the and symbol. So question mark says, hey, the start of the query string, first query, second query. Now Google probably doesn't understand the second query because that's not something that they have built in, so we want to just keep it to the queue. But let's go ahead and print. So if we print that URL, you can take a look and see that the query string is working just fine as you normally would expect it to. But let's go ahead and pull up Google real quick and change this out with the question mark so it matches our query string. And you can see that Google doesn't know how to respond to that. So that's kind of a problem. And that's a problem that requests, I'm not sure, has a solution to. So the harder way of doing something like this would be to simply say, you know what, we're not going to do params, and because Google wants to be special and different, we would now need to say, you know what, list of links, and we'll say plus Now we can say # and just say Q equals test. So let's see if the URL works. So when we print the URL, okay, it says cannot concatenate string to a list. Okay, so we need to explicitly state, hey, you're not a list item, you're a string. Oh, you know what? I see what I'm doing wrong. Okay, my bad. I'm not even doing this in the right spot. Why didn't you guys tell me that? That was stupid of me. Alright, so what I was talking about is I'm trying to do it here. You guys were like, what the hell are you doing? Alright, so here is where we would say Q equals test. You know what? Let's just do it like that. No, I probably don't even need that, actually. Let's do that. Alright, now let's try it. Alright, so now the URL is right. So the question, I mean, is do we get any sort of different text? And really, you'd have to go and compare what we got before to what we're getting now in order to see what's going on there. But I mean, obviously, I don't remember what was there before. It looks like we got quite a bit more content going about it this way. But who knows? All that stuff is all jumbled together into a big mess. In most cases, you're not really going to be, searching Google using something like this because number one, they don't even allow it. Number two, you should be using an API. So Google has like a search API that'll allow you to use them, and they give you a lot of free resources, like 50,000 requests a day or something like that before they even try to charge you any money. So most small-time website owners, they wouldn't have to pay anything in order to tap into Google, but you have to get like approved by them so they can give you a client key and a secret key, and that way you can pass those values up every time you make a request. But by using an API with something like Python requests, you're going to be so much better off than trying to do web processing the old way. Because back in the old days, like with Perl and stuff like that, we used to always grab source code and then save it as a text file and stuff like that. And then we'd go through the text file and look for links using regular expressions and all this other garbage to try to find all the anchors. And then we put all those anchors into another Python list and iterate through the list like I showed you how to do, requesting more pages and grabbing all their links and adding it to the list. You know what I mean? So you can create this endless, monster of a search engine looking for data. And that's something that Python request is definitely built to do. So that's really going to be where we touch base on this. I mean, where we stop on this this tutorial series. There's quite a bit more that you can do on Python requests, but I think I'd be getting into more advanced level stuff. And hopefully you guys like this format. Like I said, none of this was scripted or anything like that. This is all just going off the cuff and making mistakes and trying to spot those mistakes and things like that. So you can see, a lot of this stuff is just basically, okay, here's a get. We know about other gets, and then r.json, it turns it to actual JSON data. So if you guys know what JSON data is, it's JavaScript object notation. You can read things like, so you can use chunks. So if you have like a large image or something like that, you can break it up into chunks. You can do custom headers. So if you want to disguise your user agent, you can do that. You can't hide your IP address or anything like that, but you can change your user agent. So if you're using Chrome, you can say, hey, I'm using Mozilla, even though you're really not even using a browser because you're using Python explicitly to reach across the web. So, and then, with the payload data, like we saw Google has the weird query string that has a pound symbol where in most cases you're going to see the question mark. So if you want to use the payload data, that's fine there. So we really touched on all this stuff. And then as far as posts are concerned, when you post data versus get data, you guys should know the difference between that, hopefully. But typically, whenever you're making a request for something, you're going to use a get. And whenever you want to change data on the server somewhere, you're going to use a post. And other than that, guys, I mean, that's about it. This is a relatively small library, but it's a powerful library. It's better than the old libraries like we have with URL lib and everything. So you can see there's a lot of stars on GitHub, so it's pretty popular. Anyway, guys, take care. Please subscribe to this channel if you want more tutorials like this, and thanks for watching. Have a good day. Bye.